Hello everyone, I'm Ben, the Business Development Manager from Small Panel Supply, and my colleague, Honest, the Project Manager. We would like to give a brief presentation on heat recovery ventilation system. Before the presentation starts, we would like to give you some idea about the organization we come from, Small Panel Supply. It was established in 2010. Our headquarters is in the United States, and we are looking hard to promote energy efficiency mechanical system and construction materials. There are four objectives we would like to achieve at the end of the presentation. Number one, we would like you to identify the pros and cons of supply, exhaust, and balanced ventilation system. Number two, discuss how HRV enable a comfortable and healthy environment. Number three, determine the role of HRV system. And finally, you can evaluate HRV system and select the most effective system. So in the following presentation, we will go through these five topics: mechanical ventilation and energy efficiency, type of ventilation system, heat recovery ventilation systems, selecting an HRV system, and finally, we'll do the machine demonstration. Mechanical ventilation and energy efficiency. So why is mechanical ventilation important? As nowadays the passive house normally facility a very good air tightnesses. As a result, it have a very low energy consumption, but the air infiltration is low as well. So it will raise a lot of moisture, mold control, air pollution, health and comfort issue. So what are the types of the ventilation systems? Many typical American homes follow ASHRAE standard 62.2-2022 regarding ventilation. And in this standard, it will give you an idea of required flow rate in some of the room and any other requirements. For the ventilation, there are three types. Let's look at the exhausted ventilation. It is the most typical in the old building. Bathrooms and the range hoops expel air from the wet space, as the makeup air may enter the interior space through the cracks and the nicks. It will contribute a poor air quality. Supply ventilation push the outside air into the room. Stale air exits through the random nicks and the controlled damper. Of course, it can eliminate the problem of the air quality, but you need to have much higher energy to compensate the heat loss, especially in the winter. Finally, balanced ventilation. It mainly uses the HRV to manage the makeup and exhaust the air. This type of ventilation increases the cost effective and energy efficiency. And also it can improve the interior comfort level and the air quality as well. So we'll look at the air recovery ventilation system. So basically, HRV system can simply say it is a balanced ventilation system that provides the comfort, health, and energy efficiency. Before we go through the detail of the HRV, we'd like to show the performance first. Now we have a condition, a single family home with 3 bedrooms, 1 bath, 1,500 square feet for the area, and 8 feet height. By calculate according to required airflow rate 60 CFM, and the outside temperature is about -1 degree Celsius, and inside air temperature will be 21 degrees Celsius relevant to the 70 degree Fahrenheit. If we only use the bath sense by considering 60 CFM continuously required, and in a day maybe we use somehow the boost mode at certain period of time, that is 120 CFM intermediately. So by calculating with the heat loss, we will come up with 72,000 something BTU per day energy consumption. And the makeup air temperature is around 30 degree Fahrenheit. But if we apply the HRV, and the HRV only have the 75% efficiency, we only concentrate how many heat loss from the home system. That is the energy we need to compensate to the heat loss in the room. As a result, we only need to have 15,000 BTU per day, and the makeup air can come up to 60 degree Fahrenheit. What if we apply high efficiency HRV, 90%, we just need 6,000 something BTU per day, and the makeup air can come up to 66 degree Fahrenheit. So compared with original air temperature inside the room 70, it just have a very minor heat loss. And also we just need a very less energy on this situation. So the result conclude HRV can reduce the energy penalty associated with the mechanical ventilation and help to balance the temperature inside and outside. So selecting the HRV system. In this section, we will put more focus on the machine. Here are the main components. So the heat exchange heat exchanger shown in the green color, and here is two filter in the gray color, and the fans and the motor will put inside the red box, and the control system at the bottom of the machine. The basic operation is shown at the left. Cold fresh air and the warm interior air enter the coil, and inside the coil the heat exchange is take place. And as a result, the temperated air will return to the room, and the exhaust air will be expired to the atmosphere. In the summer, if we don't need any high temperature air inside the room, we don't need to have a heat exchange and want to exhaust the air directly to the atmosphere. We have the summer bypass mode. About the sizing, we normally design 60% of HRV maximum capacity at the continuous operation, and we leave some room for higher setting on the boost ventilation, for the bathroom, for the kitchen when it is required. There are 3 steps in the installation. Starting from running the comfort tube and comfort flex in the ceiling. Then we need to fix the location of the diffuser and the register and connect all the piping to the machine. We can also put the cylinder or extra filter if it is necessary. Many users will worry about the temperature below freezing. So what our strategy on that? In the market, there are 3 strategies. And today we only focus on what we recommend preheat force prevention strategy. According to a study from Brian Just, it shows the carbon dioxide concentration drop with a continuous of air delivery. So at the left hand side, we will see the carbon dioxide level is very high at certain period of time. And at the right hand side, if the supply air continuously delivered to the bedroom, it shows it that the level of carbon dioxide sharply drops. If we use only the exhaust only defrost strategy, we need to have a high energy consumption to compensate the heat loss. But if we use the preheat strategy, yes, we need to have extra energy consumption on the preheater. But as a result, we have only half of the energy consumption to compensate the heat loss. After the machine demonstration, please feel free to share your idea if you have. Now we pass the time to my colleague, Carlos. Thank you.